nonlinear regression. So what is nonlinear regression? Well, nonlinear regression is a form of regression analysis in which the observational data is modeled by a function that's a nonlinear combination of the model parameters, and it depends on one or more independent variables. So it could be used when the number of predictors is large, and let's say prior to fitting a regression model with all the predictors, we might want to use something like stepwise regression, which in short sequentially adds variables one at a time into a model to identify which increase the accuracy, or R squared, respectively. And we do this to screen out predictors that are not associated with the responses, that output, that target, that criterion, that Y variable. Because if we had 10,000 variables, that could deeply penalize our model. But if we find out that only 10 actually increase R squared, then it's much more effective for building that model. So let's go through the types of nonlinear regression. First is a polynomial function. A polynomial regression is a form of regression analysis in which the relationship between the independent variable x and the dependent variable y is modeled as an nth degree polynomial. Now, where you actually see this isn't the b subscript 0 or b subscript 1x1 or b subscript 2x2. It's these other areas where you have b subscript 1 x1 squared, b subscript 2 x subscript 2 squared, and that is creating this polynomial function. So if our data on a scatter plot looked like it was reflecting this graph, then we should build a polynomial function model. There's also logarithmic functions. So logarithmic regression is used to model situations where growth or decay accelerates rapidly at first and then slows over time, like how long drugs stay in someone's system. And so here we have the equation y equals b subscript 0 plus b subscript 1 natural log x1. Now it could be log base 10, log base 6, whatever, but here we use the natural log, plus b subscript 2 natural log x2, which creates functions that look like the blue and yellow lines below. We also may have a square root regression, and that's used to model situations to improve the distribution of the dependent variable. And here you see at b1, we have the square root function on x subscript 1, b2, the square root of x subscript 2. So what we're doing is taking the square root of the original variable to model it to better fit a line that's nonlinear in composition. We could also have a reciprocal. So this could be used for stronger curved relationships. And we use that by doing 1 over x subscript 1, 1 over x subscript 2. And lastly, we have exponential functions. So an exponential regression refers to the process of deriving the equation of the exponential function that fits best for a set of data. So if things tend to increase or decrease exponentially as continuous growth or extreme decay, then we might use e to the power and then put the equation there. And that way the entire equation is actually an exponential function. Now, what are the limitations to linear regression modeling? Well, while building up the linear regression equation, the following challenges could occur. The sample of data analyzed for the regression model could be biased, could potentially not reflect the actual population. It depends how we sampled that data, where it came from, as well as the accuracy of the data itself. Now, the model developed may also be a good fit for the existing data set, so you may get a great R-squared data accuracy, but if you applied it to new data, the accuracy could drop drastically. And so if we used all the data to train the model, then we'd have no data to test if the accuracy is good with new types of data. So to overcome such challenges, we're going to use something called cross-validation.